assembly language development means based on the assembly level, language level. There's ASM or ALP, how to develop the software part in the embedded system. Actually, the ALP program, there's a assembly language program. Okay, the ALP written in the assembly code, and then that file will be saved in a .asme or .source file. Okay, there it is also can also .s files also, otherwise .src source files. Again, any text editor link, there's a notepad, means by using any test. Okay, you can see an example in operating systems. We have a WordPad also, there we have a notepad also, there are some of the Microsoft files also will be there. You can use those files to write the programs. That software, that application should be integrated with this assembly instructions. Okay, that means if you can use a notepad, also we can use a WordPad. That it can as a text editor provided by the integrated development tools can be used for the writing the assembly instructions. ಅರ್ಥ ಆಗ್ತದೆ ಅಂದ್ರೆ ನಾವೇನಪ್ಪ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಈ ಎಂಬ್ರಾಯ್ಡ್ ಸಿಸ್ಟಮ್ಸ್ ಅಲ್ಲಿ ಈಗ ಎಂಬ್ರಾಯ್ಡ್ ಸಾಫ್ಟ್ವೇರ್ ಡೆವಲಪ್ಮೆಂಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ನಾವು ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಪ್ರೋಗ್ರಾಮ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ದಟ್ ಪ್ರೋಗ್ರಾಮ್ ಶುಡ್ ಬಿ written in the assembly code and it is saved in a .asm or .s files or .src files. ಓಕೆ, ನಾವು ಈ ತರ ಅಸೆಂಬ್ಲಿ ALP ಪ್ರೋಗ್ರಾಮ್ ನ ಎಲ್ಲಿ ಬರಿಬಹುದು ಅಂದ್ರೆ ನೋಟ್ ಪ್ಯಾಡ್ ಅಲ್ಲಿ ಆಗ್ಬೋದು, ಅದ್ರ ವರ್ಡ್ ಪ್ಯಾಡ್ ಅಲ್ಲಿ ಆಗ್ಬೋದು. ಓಕೆ, ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು ಬರೆಯಲಿಕ್ಕೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್. Again, similarly, C and other high-level language programs, we have a multiple source files called as modules. Okay, in the assembly language programs. Okay, each modules can be represented as a .asm or .src. Okay, this approach is called as a modular programming. Modular programming is nothing but we can we can divide it into sub modules. Okay, each module is made with the reusables. Okay, splitting the main programs. Suppose if you can example, the main program will be too long or it may too big or it's too complex. Then what will you do means we go for the divided that program. Okay, that divided program is called as a sub modules. Okay, we can easily reusable the each modules. Okay, where we have to use, suppose the same application can use for the other applications. Okay, you've taken the same modules. Okay, again will be flashed into the particular systems. It will be work based on your control flow. Okay, the modular program are usually easy to code, debug, and you can also alter the programs. Okay, what you see in this figure, that is the assembly language to machine language conversion process. How the assembly code is converted into a machine code. Okay, that's nothing but assembly language to machine language conversion process. Okay, as usual, already you know that how to convert these to machine language. Okay, initially what you do means first initially all the course modules. Okay, is written in a assembly and it is stored in a .src or .asm. Okay, again each files can be assembled separately to examine the syntax error and incorrect assembly instructions. After successful assembling the each source files or each ASM files and file for a corresponding object files is created with the extension of OBJ. Okay, using the .obj, we can creating the object files. See, the object files does not contain the absolute address, whereas the generated codes needs to be placed on the program memory, and hence it is called as a relocated segments. And also it can be placed at any code memory location, and it is a responsibility of the linker locator to assign the absolute address from these modules. See, after that after creating the corresponding objective file will be creating from this assembly language, then we'll go for the creating the library files. So the library with creation and then usage. See, in the library, dear student, it is audible now? Say yes or no? It is visible now? The presentation is visible, say yes or no?
Yes, sir.
Okay. Please hold a minute. Please hold a minute. Please hold a minute. It takes some time to rejoining the session. Okay, dear sir, sorry for unable to, because of network issues, I'm not able to share the screen. Okay, just I'm giving the overall explanation about the how the process will be going on. It converted as assembly language to machine language process. See, after that, creating the objective files, then you go for the creation of the library files. Okay, libraries are specially formatted and ordered program collection of object models that may be used by the linker at the time. Okay, see how to do the generation of this library files means with extension of library lib dot library you do the creations will be done, and then after that library process will go for, then we go for the linking process. When the linker process a library, only those object models in the library that are necessary to create the program are used. Okay, once the library file is some kind of source code, hidden hiding techniques. For example, LB library 51 for kill software is example for library creator, and is used for creating the library function for assembly language, means assemblers, as a compiler for 8051 specific microcontrollers. Then after that, wait. Because network is too low, sir. this offline, sir. Network illa, sir. College do. Okay. See, after that, so that object, next conversion is the object to Excel file converters. Okay, this is the final stage. Okay, this is the final stage. The conversion of the assembly language to machine understandable language. That is called the machine code. Excel file is the representation of the machine code, and Excel file is dumped into the code memory of the processor or controllers. The Excel file are representation the various depending upon the target processor and controllers make. Actually, the Excel files are ASCII files that contains the hexadecimal representation to target applications. And also this Excel file is created from file absolute object files. Use the object to Excel files convert utility. Okay, OH51, there is a form kill software is an example for object to Excel file conversion utility for assembler compiler 51 for 8051 specific controls. Okay, there is a last stage for converting the machine code. Okay, that's assembly code to machine code. There's a creation of XML. Okay, initially we know that if you write something, some program, LP program, and the kill software, so it should be written in the form of XML only initially. Okay, that's why suppose if you take an example, move a comma slash 58. Okay, everything should be converted into X only initially when doing the laboratory. But this is the final stage. Okay, object. Okay, what the object will be converted into XML. Okay, this is the final stage for the conversion of assembly language to machine understandable language. Okay, next is the what is the advantage of the assembly language based development? Okay, what are the advantages? Suppose if we can use for ALP type, what are the advantages? See, in this, what is the first advantage is the efficient code memory and data memory usage. Okay, there's one of the example here. That is efficient. You can efficiently use the codes memory, code memory, and then data memory usage. Okay, we can call it the memory optimization. Optimization means efficiently we can use the both code as well as the data memory usages because of using this ALP program. That's the one advantages will be there. Okay. The second one is the high performance. Okay, high performance. That is the second advantages. Okay, suppose if you take an example, efficient code memory and data memory usages. Actually, the developer is well works with the target processor architectures and memory organizations. Optimization codes can be written for performing the operations, and we can use this kind of ALP can utilize of code memory or code memory and efficient utilization of the data memory. Okay, this leads to utilize less utilization of the code memory and then efficiently utilization of the data memory. Next advantage is the high performance. Optimized code. Okay, optimized code means efficient code not only improves the code memory usage but also improves the total system performance. And now efficient code na ನೀವು ಬರೆದ್ರೆ ಏನಾಗುತ್ತೆ efficient ಆಗಿ the system performance also goes on increases. Okay, that's why through effectively assembly coding, optimum performance can be achieved for the target applications. Again, the next one is the this ALP. Initially, I told you people the ALP can use for the low-level embedded systems. Okay, it is a low-level embedded system. So one of the advantages we can access the low-level hardware access. Okay, see most of the code for the low-level programming, like accessing external device-specific registers from the operating system, kernel, device drivers, and low-level interrupts, routines, etc., are making a use of direct assembly coding, since low-level device-specific operation support is not commonly available with most of the high-level language class compilers. Okay, there's a one type of advantage is given from this ALP, can access the low-level hardware also. And then the next important advantage is the reverse engineering. Okay, code reverse engineering. Okay, we can easily recap the what is the means we can easily understandable about the program. So okay, we can do the reverse reverse engineering also you can do. Will get understanding the what is the exact process in that particular programs. Okay, actually this is one kind of reverse engineering. That is one kind of the process of understanding the technology behind a product by extracting the information about the from the finished product. ಅಂದ್ರೆ ನಾವೇನ್ ನಾವು ಪ್ರಾಡಕ್ಟ್ ರಿಲೀಸ್ ಆಗಿರುತ್ತಲ್ಲ ಆ ಪ್ರಾಡಕ್ಟ್ ನಾವು ಕಂಪ್ಲೀಟ್ ಆದ್ಮೇಲೂ ನಾವು ಈಸಿಯಾಗಿ ಅದರ್ ಪರ್ಸನ್ಸ್ ಆಲ್ಸೋ ಕ್ಯಾನ್ ಯೂಸಿಲಿ ಐಡೆಂಟಿಫೈ ಅಂದ್ರೆ ಈಸಿಲಿ ಯಾವ ತರ ಫ್ಲೋ ಆಗ್ತಿದೆ ಅಂತ ನಾವು ಈಸಿಲಿ ರಿವರ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ ಆಲ್ಸೋ ನಾವು ಡಿಕೋಡ್ ಮಾಡಬಹುದು. ಓಕೆ, okay, that's the and those most of the products employ the code memory operation. It may be possible to break the memory protections and read the code memory, and it can be easily be converted into assembly code using a disassembly program for the target machines. ಅಂದ್ರೆ ಅವೇನ್ ರಿವರ್ಸ್ ಇಂಜಿನಿಯರಿಂಗ್ ಏನಪ್ಪ, ರಿವರ್ಸ್ ಉಲ್ಟಾ ಇಂಜಿನಿಯರಿಂಗ್ ನಾವು ಆರಾಮಾಗಿ ನಾವು ಅದನ್ನ ರಿಕವರ್ ಮಾಡ್ಬೋದು, ಏನ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಇದೆ ಎಲ್ಲಿ ಸ್ಟೋರ್ ಆಗಿದೆ ಮತ್ತೆ ನಾವು ಡಿಕೋಡ್ ಮಾಡ್ಬೋದು ಆರಾಮಾಗಿ. ಓಕೆ, ಈಸಿಲಿ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅಸೆಂಬ್ಲಿ ಕೋಡ್. ಓಕೆ, ಏನೆಲ್ಲ ಫ್ಲಾಶ್ ಆಗಿತ್ತಲ್ಲ ಮೆಮೊರಿಗೆ, ಏನ್ ಪ್ರೋಗ್ರಾಮ್ ಫ್ಲಾಶ್ ಆಗಿದೆ ಅನ್ನೋದನ್ನ ನಾವು ಆರಾಮಾಗಿ ಡಿಕೋಡ್ ಮಾಡಬಹುದು. ಓಕೆ, ಅಗೇನ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಅಸೆಂಬ್ಲಿ ಕೋಡ್ ಬೈ ಯೂಸಿಂಗ್ ದ disassembler program for the target machine. Okay, that is a one advantage given. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? And what is the drawback for this one? Okay, this kind of system that not operating in the real time. Okay, there's a high development time. Okay, assembly language is much harder to program the high level languages. Okay, high level language ಇದಕ್ಕೆ ತುಂಬಾ ಕಷ್ಟ ಆಗುತ್ತೆ ಇದರಲ್ಲಿ. And the developer must pay attention to more details and must have through knowledge of the architecture, memory architecture, and the details of the target processor in use. ಡೆವಲಪರ್ ಏನಾರ ಈ ALP ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ ನೀವು ಬೇಸ್ ಮೇಲೆ ನೀವು ಪ್ರೋಗ್ರಾಮ್ ಬರೀಬೇಕಂದ್ರೆ you should know what is the initial architecture of the particular microcontroller, microprocessor, memory organizations, and register details. Okay, the target register details about that particular processor or microcontrollers. For writing the program, you should know these things. And learning the inner details of the processor and this assembly instruction is highly time consuming, and it creates the delay impact in the product development. Okay, before you to writing this kind of programming, so you should know that what are the instructions are there, what kind of processor details. Okay, processor details also will be required, and assembly instructions also will be before you should learn those things. Okay, because of learning these two kinds, it consumes more time, and also it creates a delay to produce a higher product. Also, more lines of assembly codes are required for performing an action, which can be done with a single instruction in a high-level language like C. Okay, if you want to perform one instruction, okay, suppose if you take an example, one data will be there, that will be stored in the memory, and that data will be moved to the load to the particular instructions. We need some of the 4 to 5 instructions will be there to do that one single instruction processing. For this kind of language, that's one of the drawbacks. Suppose if you go for the high-level language like C, within a one single instruction, you can load or store the content of the data in the memory or the registers. That's one of the drawbacks. That's why it takes high development time. Okay, this is one drawback is the high development time. And then the second drawback is the developer dependency. Okay, developer dependency. Unlike high-level language, there is no common written rules for developing the assembly language based. In assembly language programming, the developer will have the freedom to choose the different memory location and registers. Okay, it means if you want to write this assembly language program, the developer they choose the things dependency. Okay, developer should be dependent with that particular rules and regulations. Okay. And also, the program approach varies from developer to developer depending upon their taste. Okay. And also, dependency will be there. Okay. It is not dependent upon the project. Okay. That program could be totally dependent upon the developers. Okay. Developers skill may loಗುತ್ತೆ. Developers ಯಾವ rules ನಾವು follow ಮಾಡ್ತಾರೆ for developing the assembly language based applications ಆಗ್ಬೋದು. Again, the developer can choose any kind of any way to write the programs. Okay, and the memory locations, so choosing the different memory location register, that will be totally dependent upon the developers. Okay, and then if you take an example, Suppose taken data, any one data can move from memory location to the computer can be achieved through different approaches. One data is the memory location, moving the data from memory location to accumulators. Okay, there were different types of approaching. Okay, developer can use the different instruction. We can do that particular task. Okay, that's why what is the conclude of this can is the totally the writing is assembly language based programs. Okay, totally dependent upon the developer. Okay, is there means how they are developing. Okay, how much time they will take, and then design that approaches. Okay, different approaches they will use for writing the program. Okay. And then suppose in this approach, what happen? The developer is not documented properly at the development stage and may not able to recollect this means in starting stage. Actually, the developer is not documented properly. Okay, the later stage, what happen? If initially they are not documented properly, means very difficult to recollect things. Okay, in the later stage. They're not unable to recollect the data. Okay, that's the thing. And also suppose suppose the same program will be what is it? Re-altered or reconfigured. Suppose we take an example of a new developer will become to the particular work means that new developer will be analyzing is not able to understand what they done and why it is done. Okay, because of they are developer they will take different way approaches how to write the assembly language. Okay, one developer will be different, other developer will be different characters. Okay, they are writing different way. Then the new developer came for working on that same programs. They will take some time to recover that, and also it is very difficult to understand why they are using what is done, what is going on the particular program, why it is done like that. Yes, upgrading an assembly programs or modifying it is on later stage is very difficult because of this. The overall program will be depend upon the developers. Okay, on developer ಯಾವ ತರ ಬರೀತಾನೆ, ಯಾವ ತರ ರೂಲ್ಸ್ ಫಾಲೋಸ್ ಮಾಡ್ತಾನೆ, ಯಾವ ತರ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮಾಡಿರ್ತಾನೆ, ಓಕೆ ಯಾವ ತರ ಕಾನ್ಫಿಗರೇಷನ್ ಮಾಡಿರ್ತಾನೆ ಅನ್ನೋದು ಗೊತ್ತಾಗಲ್ಲ ಬಿಕಾಸ್ ಆಫ್ ಅವನ ವೇಲಿ ಅವನು ಬರ್ದಿರ್ತಾನೆ. ಸಪೋಸ್ ನ್ಯೂ ಪರ್ಸನ್ ಬಂದು ಅದೇ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲೇ ಮಾಡಬೇಕು ವರ್ಕ್ ಮಾಡೋದಕ್ಕೆ ಹೋದಾಗ ಡಿಫಿಕಲ್ಟ್ ಆಗಿರುತ್ತೆ. Okay, ಅದಕ್ಕೆ ಏನಂತಾನೆ upgrading. Suppose the same system can be upgraded or modified. Okay, in the later stage it's very difficult. That's one kind of drawbacks. And then one more drawback is that not portable. Okay, what is that? Not portable. The target application written in assembly instructions are valid only for that particular family or process and cannot be reused another target processor or controllers. Okay, ನಾವೇನು ಅಪ್ಲಿಕೇಶನ್ ನಾವೇನು ಪ್ರೋಗ್ರಾಮ್ ರಿಟರ್ನ್ ಬರೀತಿದ್ವಲ್ಲ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರೊಸೆಸರ್ಗೆ ಮಾತ್ರ ನಾವು ಬರ್ತಿದ್ದೀವಿ. ಆ ಪ್ರೊಸೆಸರ್ಗಿಂತ ಸೇಮ್ ಡೇಟಾ ನಾನು ತಗೊಂಡು ಬೇರೆ ಪ್ರೊಸೆಸರ್ಗೆ ಹಾಕ್ತೀನಿ ಅಂದ್ರೆ ಅದು ಯೂಸ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ. ಅದರದ್ದು ನಾಟ್ ಪೋರ್ಟಬಲ್. ಅಂದ್ರೆ ನಾವೇನ್ ಪ್ರೋಗ್ರಾಮ್ ಬರ್ತಿದ್ವಿ ಅದು ಆ ಪ್ರೋಗ್ರಾಮ್ ಮಾತ್ರನೇ ಅದು ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ, ಪ್ರೊಸೆಸರ್ಗೆ ಫಿಕ್ಸ್ ಆಗಿರುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್, ಸಪೋಸ್ ಇಫ್ ಯು ರೈಟ್ ಇನ್ ದಟ್ LP ಪ್ರೋಗ್ರಾಮ್ ಫಾರ್ 8086 or 8051 microcontroller ಅಂದ್ರೆ ಅದಕ್ಕೆ ಯೂಸ್ ಮಾಡೋದು. ಓಕೆ, ದ ಸೇಮ್ ಪ್ರೋಗ್ರಾಮ್ cannot be used for the ARM7 or ARM11 family of processors. Okay, that's why it is not portable. And then if the target processor or controller changes, a complete rewriting of the application using the assembly instruction for a new target processor and controller is required. ಅಂದ್ರೆ ನೀವೇನಾರ ಇನ್ನೊಂದು ಹೊಸದಾಗಿ ಅಪ್ಲಿಕೇಶನ್ ಮಾಡಬೇಕು, ಇನ್ನೊಂದು ಪ್ರೊಸೆಸರ್ ತಗೊಳ್ಬೇಕು ಅಂದಾಗ ಏನ್ ಮಾಡ್ತೀರಾ, ಮತ್ತೆ ನೀವೇನು ಕಂಪ್ಲೀಟ್ ರಿರೈಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಪ್ರೋಗ್ರಾಮ್. Okay, ಯಾಕಂದ್ರೆ ಪ್ರೀವಿಯಸ್ ಪ್ರೋಗ್ರಾಮ್ಸ್ ಏನಿರುತ್ತೆ ಅದನ್ನ ನಾವು ಯೂಸ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ. That's why it cannot be reused for the another target and processor controllers. ಅರ್ಥ ಆಗ್ತಿದೆಯಾ? ಈಗ ನಾವು 8051ಗೆ ನಾನು ಪ್ರೋಗ್ರಾಮ್ ಬರ್ದಿರೋದು ಅದೇ ಪ್ರೋಗ್ರಾಮ್ ನಾನು ARM ಮೈಕ್ರೋ ಕಂಟ್ರೋಲರ್ಸ್ಗೆ ಬರೆಯೋದಕ್ಕಾಗಲ್ಲ. It is not fixed, it is not portable. ಅಂದ್ರೆ ಅದು ಕರೆಕ್ಟ್ ಆಗಿ ಆಗಲ್ಲ. Okay, what do you do if you want to advancing or enhancing the particular system means if you once again if you rewrite the whole the program ಯಾರಿಗೆ for the target processor or controller is required. Okay, that is one kind of drawbacks. Okay, it is not a portable. Okay, next topic is that high level language based program. Okay, as usual, high level language program is nothing but C, C++, Java. Okay, these are the high level language program. Okay, now it is visible now. Presentation is visible. Say yes or no. Hello. Hello, dear students. Either of you. Okay. See, the next is the high level language based development. Okay, high level language is nothing C, C++, Java. Now it is a Python will be there. Okay, which is supported cross compiler for a target processor on the ಈ ಲ್ಯಾಂಗ್ವೇಜ್ ಹೆಂಗ್ ಸಪೋರ್ಟ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಕ್ರಾಸ್ ಕಂಪೈಲರ್ ಇಂದ ಯಾವ ಟಾರ್ಗೆಟ್ ಪ್ರೊಸೆಸರ್ ಅಂದ್ರೆ ನೀವು ಯಾವ ಪ್ರೊಸೆಸರ್ ಅದು ಯಾವ ಕಂಟ್ರೋಲರ್ ಕ್ಯಾನ್ ಬಿ ಯೂಸ್ ಫಾರ್ ದಿ embedded framework development. Then most of the commonly used high level language for embedded software application is development is C. Okay, C is a well defined, easy to use high level language with the extensive cross platform development tool supports. Okay, and then again maximum high level languages ಅಂತ ನಾವು ತಾಳೋದು C, C++ ನಾವು ಯೂಸ್ ಮಾಡಿದ್ವಿ C because of it is very easy to understand. It is a high level language by using some of the supporting tools. We can design the softwares. See, nowadays there's a cross compiler for C++ is also emerging out. And the embedded developer are making the use of C++ for embedded application development. Okay, C ಆದ್ಮೇಲೆ C++ ನ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಯಾಕಂದ್ರೆ there's a cross compiler. We are using some supporting tools, supporting platform, using that for that particular C++. Okay, then again it's a high compared to the C. There's an extension to C++ will be there. It can also C++ language also you can use for through developing the control softwares or embedded softwares. And then there is a various steps are involved in the high-level language-based embedded framework development. It is same as that assembly language-based development, except the conversion of file in a high-level language to object file is done by the cross compilers. Okay, now assembly language level ಯಾವ ತರ ನಾವು conversion ಮಾಡ್ತಿದ್ದೋ first ಏನ್ ಮಾಡ್ತಿದ್ದೋ ಏನ್ ಮಾಡ್ತಿದ್ದೋ ಫಸ್ಟ್ ಆಬ್ಜೆಕ್ಟಿವ್ ಮಾಡ್ತಿದ್ದೋ ಓಕೆ ಮೀನ್ಸ್ ASM ಲ್ಯಾಂಗ್ವೇಜ್ ಸೋರ್ಸ್ ಫೈಲ್ ಅಲ್ಲಿ ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡ್ತಿದ್ದೋ ಆಮೇಲೆ ಆಬ್ಜೆಕ್ಟ್ ಫೈಲ್ ಗೆ ಲಿಂಕ್ ಮಾಡ್ತಿದ್ದೋ ಆಮೇಲೆ ಲೈಬ್ರರಿ ಫೈಲ್ ಗೆ ಲಿಂಕ್ ಮಾಡ್ತಿದ್ದೋ ಆಮೇಲೆ ಫೈನಲಿ ಎಕ್ಸೆಲ್ ಫೈಲ್ ಗೆ ನಾವು ಕನ್ವರ್ಟ್ ಮಾಡ್ತಿದ್ದೋ. The same thing here also, everything will be done same for procedures also will be followed in this high level language based development. Okay, here in this case, the software, the language based development accept that conversion of source file written in the high level language to object file is done by the class compilers. Okay, in assembly language based development it is carried out by an assembler. Here it will be done by the class compilers. And then there is a various steps involved in the conversion of the program written in the high level language to corresponding binary files or machine language. Okay, you can see in the figure also there is a conversion figure also will be there. See, this is a way to converting that high level language to machine language conversion process. Okay, here also there is a model wise. Okay, step by step will be there. Okay, each file will be stored in the .c. Okay, now previously ಯಾವ ತರ ನಾವು source file ನಾವು save ಮಾಡ್ತಿದ್ದು .asm or .src or .s files. Okay, here the first thing. Okay, if you want to writing something some program in any of the high level language, suppose you take C, C++, that file should be saved in the corresponding language extensions like .c or .cpp. Okay, suppose you can use C++ language, then you can use the .cpp. If you can use the C, then you can the file will be saved in the .c. Okay, any text editor, okay, any text editor like Notepad or WordPad from Microsoft or the text editor provided by the integrated development tool can be used for writing the programs. Okay, ಯಾವುದಾದ್ರೂ ನೀವು text editor ನೀವು program ನೀವು ಬರಿಬಹುದು. And most of the high level languages okay actually support the modular program approach and can be, and hence we can have multiple source files modules written in the corresponding high level language. Okay, ಇಲ್ಲಿ ಏನಾಗ್ತದೆ ಮಾಡ್ಯುಲರ್ ಆಗಿ ನಾವು ಪ್ರೋಗ್ರಾಮ್ ಬರೀತೀವಿ. ಮಾಡ್ಯುಲರ್ ಆಗಿ ಸಪ್ರೇಟ್ ಟಾಸ್ಕ್ ಒಂದೊಂದು ಸಪ್ರೇಟ್ ಮಾಡಲ್ ಆಗಿ ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಸ್ಪ್ಲಿಟ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಿ ಪ್ರೋಗ್ರಾಮ್ಸ್. Okay, and then this there is a source file corresponding to each module is represented by the files with the corresponding language extensions. And translation of high level source code to executable object code is done by a cross compilers. Okay, now again source file ನಾವು create ಮಾಡಿರ್ತೀವಿ, ಆ source level ನ ನಾವು ಈಗ object code ಆಗಿ ಯಾವ ತರ ನಾವು create ಮಾಡ್ತೀವಿ by using this cross compiler. You can see observe that there is a first is the source file, one is that will be PPP model. Okay, that will be converted into modular. Okay, the object file that will be done by the cross compilers. Okay, translation of high level source code to executable code objective code is done by the cross compilers. Each high level language should have a cross compiler for converting the high level source code into a target processor machine code. Okay, C51. Okay, there is C51 cross compiler for Kill Software is an example for the cross compiler used for the C language for the 8051 family of microcontrollers. Okay, C51 ಅನ್ನೋದು ಒಂದು cross compiler. Suppose ನಾವು Kill Software ನಾವು ಯೂಸ್ ಮಾಡೋದಾದ್ರೆ ಈ ಕಂಪೈಲರ್ ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ for conversion to software to object files. Okay, conversion of each module source code to corresponding object file is performed by the cross compilers. Okay, conversion. Okay, model source code in the corresponding object file ಯಾವ ತರ conversion ಮಾಡ್ತೀವಿ means by using this cross compiler. You can see in this example. Okay, you can see the diagram. And the rest of this. Okay, and the rest of these steps involved in the conversion of high-level language to target processor machine code, as same as the steps involved in the assembly language based development. Andre next ಏನ್ ಮಾಡ್ತೀವಿ ಆ ಫೈಲ್ ನ machine language conversion means high-level conversion language ಇದೆಯಲ್ಲ for the particular processor machine code ಗೆ ಯಾವ ತರ ನಾವು conversion ಮಾಡ್ತೀವಿ, what are the previous steps are used involved in the assembly language based development, ನಾವು ಅದೇ step ನ ನಾವು ಇಲ್ಲೂ ಸಹ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay. Then next is the advantages. Okay, what are the advantages are there? Okay, advantages you can see reduction development time. ಅಂದ್ರೆ reduction development means ಅಂದ್ರೆ ನಾವು ಒಂದು ಕೋಡಿಂಗ್ ಬರೀಬೇಕಾದಾಗ ಟೈಮ್ ನ ಕನ್ಸಂಪ್ಷನ್ ಇರ್ತಿತ್ತು ಜಾಸ್ತಿ ಎಲ್ಲಿ ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಪ್ರೋಗ್ರಾಮ್ ಅಲ್ಲಿ. here we can reduce the development times. Okay, see developers requires a less or little knowledge on the internal hardware detail, the architecture of the target processor and controllers. In the previous case, what happened in ALP, they know what is the microcontroller inner architectures and then architectures, hardware details. Okay, in this case, developer means who developer under yaar barítare a program, who is writing that particular program, that is called as a developers. Okay, developers requires very less data knowledge on the internal hardware details and architecture of the target process. Target means ಅಂದ್ರೆ ಯಾವ process ನೀವು choose ಮಾಡ್ತೀರಾ. Okay, targeted are choosing the particular processor and with minimum knowledge for the memory organization and register details of the target processor used as a visual and syntax of the high-level language are the only prerequisites for the high-level language based software development. Okay, ಇದು ಅಷ್ಟೇ ಯಾವ ತರ minimum memory organization ಯಾವ ತರ memory organization ಮಾಡೋದು digital details ಎಲ್ಲ particular target process ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ನಮಗೆ ಸ್ವಲ್ಪ ನಾಲೆಜ್ ಇದ್ದರೆ ನಾವು ಈಸಿಯಾಗಿ ಬರೀಬಹುದು. Okay. And then with the high-level language, each task can be accomplished by the lesser number of lines of code compared to the target processor or control-specific assembly language-based development. In the high-level language, minimum very less number of instructions are used for writing the programs. So, if you take an example, in 8051, the more number of instructions that suppose to reduce the number of instructions that go for ARM microcode. Again, will be reduce the instructions. Okay, like that. Okay, within one single instruction, we'll do some perform the some data. So, okay, same thing. Okay, same instruction can same function can be written in the 8051 microcontroller or 8086 microprocessor can use some of the more 4 to 5 instructions required for do that particular work. Okay, in this high level language, in a single instruction, they will complete that. Can using that single instruction only, they will do that particular functions. Okay, that's why here actually you can reduce the number of lines or codes compared to the ALE. Okay, that's why reduce the development time. Okay, overall time development is nothing but designing that means designing the particular software. It takes some very minimal time. And then developer in independency. Okay, in the previous ALE is the developer dependency. Here it is independent. Okay, it is an independency. The syntax used by most of the language, high-level language, is universal. Now, ಏನು syntax slash include slash code ಅಂತ ಏನು ನಮ್ಮ syntax ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಲ್ಲ ಅದು ಎಲ್ಲದಕ್ಕೂ ಈಕ್ವಲ್ ಆಗಿರುತ್ತೆ, ಏನು ಚೇಂಜಸ್ ಆಗೋದಿಲ್ಲ in the high-level language. It is a universal and a program written in the high-level language can be easily be understood by the second person knowing the syntax of the language. Okay, syntax ಏನಿದೆ ಅದು ಗೊತ್ತಿದ್ರೆ ನಾವು ಈಸಿಯಾಗಿ ಅದೇನು ಪ್ರೋಸೆಸ್ ಆಗ್ತದೆ ಅನ್ನೋ ಈಸಿಯಾಗಿ ನಾವು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ತೀವಿ. Again, in this, if you are writing this high level language, you should set some rules and regulations for writing the code. ಅರ್ಥಾಗ್ತದೆ, ನಾವು ಒಂದು ಸೆಟ್ ರೂಲ್ಸ್ ಅಂಡ್ ರೆಗ್ಯುಲೇಷನ್ ನಾವು ಫಾಲೋ ಮಾಡ್ಕೋಬೇಕು. ಬಟ್ ಇನ್ ದ ಪ್ರೀವಿಯಸ್ ಕೇಸ್ ದೇರ್ ಇಸ್ ನೋ ರೂಲ್ಸ್ ಅಂಡ್ ರೆಗ್ಯುಲೇಷನ್. ಓಕೆ, ಅವ್ನಿಗೆ ಹೆಂಗ್ ಬರುತ್ತೆ ಯಾವ ತರ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ಸ್ ಗಳು ಯೂಸ್ ಮಾಡ್ಬೋದು, ಏನೇ ಒಂದು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಗಳು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಡಿಫ್ರೆಂಟ್ ಆಗಿ ಅವನು ಪ್ರೋಗ್ರಾಮ್ ಬರೀಬಹುದು. ಬಟ್ ಹಿಯರ್ ಇನ್ ದಿಸ್ ಹೈ ಲೆವೆಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ always consider the certain set of rules for writing the code and commenting the piece of code. And then the developer strictly adhere to the rules. Okay, the software will be 100% development independent. Okay, the developer andre ee language alli enandre you should follow some certain rules and regulations. Okay, based on that rules only you can write this primary. Okay, hangage enagutte it is very easy to understand that agar next new person bandu ade program na ಅವನು ರೀಡ್ ಮಾಡಬೇಕು, ರೈಟ್ ಮಾಡಬೇಕು, ರಿಯೂಸಬಲ್ ಮಾಡಬೇಕಾದ್ರೆ ಇನಿಷಿಯಲಿ ಏನಿದೆ ಪ್ರೋಗ್ರಾಮ್ಸ್ ವಿ ಕ್ಯಾನ್ ಈಸಿಲಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಬೈ ಯೂಸಿಂಗ್ ಬಿಕಾಸ್ ಆಫ್ ಯೂಸಿಂಗ್ ದ ಸೇಮ್ ಮೀನ್ಸ್ ಎವ್ರಿ ಡೆವಲಪರ್ ಕ್ಯಾನ್ ಯೂಸ್ ದ ಸೇಮ್ ಹಂಗೆ ಸೇಮ್ ರೂಲ್ಸ್, ದೇ ಫಾಲೋ ಸೇಮ್ ರೂಲ್ಸ್ ಟು ರೈಟ್ ದ program. And then portability. Okay, the portability means the target application within the high level language are converted into target processor controller understandable format by class compiler. Okay, an application written in high language for a particular target process can be easily be converted into another target processor controller specific application. It's a little less effort by simply recompiling the code modification followed by the recompiling and the application for the required target processor or controller provided the cross compiler as support for the processor controller select. ಅಂದ್ರೆ ನೀವೇನ ಪ್ರೋಗ್ರಾಮ್ ಬರೆದಿರ್ತಾರಲ್ಲ ಆ ಪ್ರೋಗ್ರಾಮ್ ನ ನಾವು ರೀಯೂಸಬಲ್ ಮಾಡಬಹುದು, ಬೇರೆ ಟಾರ್ಗೆಟ್ ಯಾವ್ದಾದ್ರು ಬೇರೆ ಪ್ರೊಸೆಸರ್ ಇಲ್ಲ ಯಾವ್ದಾದ್ರು ಕಂಟ್ರೋಲರ್ಗೆ ನಾವು ಅದನ್ನ ಯೂಸ್ ಮಾಡಬಹುದು. ಹೆಂಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ means using some suitable platforms. Okay, like recompiling platform ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಯೂಸ್ ಮಾಡಬಹುದು. ಓಕೆ, ಯೂಸ್ ಮಾಡ್ಬೇಕಾದಾಗ we can modify the little ಆಗಿ ಸ್ವಲ್ಪ ಮಾಡಿಫೈ ಮಾಡಬಹುದು, ಮಾಡಿ ಲಿಟಲ್ ಕೋಡ್ ಮಾಡಿಫಿಕೇಶನ್ ಮಾಡ್ಕೊಂಡು ನೀವು ಪ್ರೋಗ್ರಾಮ್ಸ್ ನ ಯೂಸ್ ಮಾಡಬಹುದು. And then we need some minimal effort may be required in the existing code to replace the target processor. And specific files we can use data files, register definition with new ones, etc. This is a major flexibility offered by the high-level language-based design. Okay, this is one kind of advantages. That's called as portability. And the limitation. Next is the limitation. Okay, in the limitation, what happened? The limitation of high language based development. Here the poor optimization of by class compiler. In the previous case, the optimization will be high. Okay, because of they can use the proper memory optimization, code memory, less utilization of code memory. The performance also because of increases. Here in this case, poor optimization by using the class compilers. Some class compilers available for high level, which may not be used in the generating the optimized target instruction. Target images created by such a compiler may be messy and non-optimized in terms of performance as well as the code size. The time required to execute the class also increases with the number of instructions. However, the modern class compilers are tending to adopt the design incorporating the optimization technique for both code size and performance. ಅಂದ್ರೆ ನಾವೇನಾದ್ರು ಕ್ಲಾಸ್ ಕಂಪೈಲರ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ನಾವು ಕನ್ವರ್ಷನ್ ಮಾಡಿಕ್ ಹೋದ್ರೆ ಮೀನ್ಸ್ ಯೂಸ್ ಮಾಡಿಕ್ ಹೋದ್ರೆ some optimizations will be reduced means efficiency will be reduced. ಅಂದ್ರೆ ಏನಂದ್ರೆ some compiler ಏನಂತ ಪ್ರಾಪರ್ ಆಗಿ ಅದು ಎಕ್ಸಿಕ್ಯೂಟ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ. Okay, just given an example also here. For example, the task actually by the class compiler generated machine instruction from a high-level language may be achieved throughout a number of instructions in the same task in task is added coded to the target processor inputs. And then see this high level the second limitation is again this high level language. Okay, see actually if you're writing this high level language program, okay, that is not low level hardware. Okay, that's suitable ಆಗಲಿಕ್ಕಾಗಲ್ಲ. Okay, if you see if you ಆ ತರ ನೀವು ಮಾಡಿದಕ್ಕೆ ಹೋದ್ರೆ efficiency bit goes and decreases. Okay, that's why one of the limitation is the not suitable for low level hardware. And then high investment cost. Okay, the investment cost required for high level language based on development tools is high compared to the ELP based software development tools. Okay, you cost tools ತಾಳಕ್ಕೆ ಹೋದ್ರೆ ನೀವು ELP software ಇದೆಯಲ್ಲ ಅದು ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ high level language software cost increase. Okay, those are the limitations. Okay, the next is the mixing. The mixing assembly and high level language. Okay, and then the mixing combination of these two can develop the software embedded firmware development. Okay, can create the embedded software by mixing the both assembly and then high level language. See, certain embedded firmware development situation may limit the mixing of high level language and with the assembly or assembly with the high level. Let's go to the vice versa. High level language and assembly language are usually mixed in the three ways. Okay, we have three ways and can combine these two languages. Okay, see the first is the mixing assembly language with the high level language, mixing high level language with the assembly language, and inline assembly programs. Okay, assembly language ಒಳಗಡೆ high level language mix ಮಾಡೋದು, high level language assembly language mix ಮಾಡೋದು, otherwise inline. Okay, ಅದರ ಒಂದು assembly program ಅಲ್ಲಿ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಲೈನ್ ನಾವು high level language ನ ಯೂಸ್. Okay, inline assembly program. Okay, these are three ways to combine these two languages. In the first case, the mixing assembly language with high level ಅಂದ್ರೆ high level language ಗೆ ನಾವು assembly language ನ mix ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅಂತ. Okay, mixing assembly language with the high level language. Assembly routines are mixed with the C in situation where the entire program is written in C and class and how do this one? ಹೆಂಗಂದ್ರೆ assembly language ನ ಯಾವ ತರ ನಾವು C language ಒಳಗೆ ಹೆಂಗ್ ಮಿಕ್ಸ್ ಮಾಡೋದಕ್ಕೆ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಯಾವ ಟೈಮ್ ನಾವು ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು. First, initially what we do is the entire program should be written in the C and the class compiler is used to do not have built-in support for implementing the certain feature like interrupt service routines functions. Okay, ಆ ಟೈಮ್ ನಾವು assembly language ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, because of this class compiler is there, ಕ್ರಾಸ್ ಕಂಪೈಲರ್ ಮಾಡೋದು ಏನ್ ಸೋರ್ಸ್ ಫೈಲ್ ಇದೆಯಾ ಅದು ಕನ್ವರ್ಷನ್ ಮಾಡೋದಕ್ಕೆ ಅಲ್ವಾ, ಮಿಷಿನ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಕನ್ವರ್ಷನ್ ಮಿಷಿನ್ ಕೂಡ ಕನ್ವರ್ಷನ್ ಮಾಡೋದಕ್ಕೆ ನಾವು ಕ್ರಾಸ್ ಕಂಪೈಲರ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, in some program what happen, this class compiler is used do not have to build in support of implementing the certain features. Okay, ಈ ಕ್ರಾಸ್ ಕಂಪೈಲರ್ some features ಇಂಪ್ಲಿಮೆಂಟ್ ಮಾಡೋದಕ್ಕೆ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ತಾ ಇರುತ್ತೆ, ಲೈಕ್ ಇಂಟರ್ಫೇಸ್ ಸರ್ವಿಸ್ ರೂಟಿಂಗ್ ಫಂಕ್ಷನ್ ಮಾಡೋದಕ್ಕೆ. ಅವಾಗ ನಾವು ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ assembly language. Okay, if the programs want to take the advantages of this trend advantage of speed and optimize the code offered by the machine code generated by the handwritten assembly rather than the class compiler generated machine code. Okay. Program ನೀವು ಏನ್ ಮಾಡ್ತೀರಾ, ನಿಮ್ಮ ಪರ್ಫಾರ್ಮೆನ್ಸ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದಕ್ಕೆ ಆಪ್ಟಿಮೈಸೇಷನ್ ಮಾಡೋದಕ್ಕೆ ಏನ್ ಮಾಡ್ತೀರಾ, ನೀವು ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಮಿಕ್ಸ್ ಮಾಡ್ಬೋದು. Okay. Rather than the class compiler generated machine code. When accessing certain low level hardware, okay, ನಮ್ಗೆ ಈಗ high level ನಾನು initially ಹೇಳಿದ್ದೆ, one is a drawback limitation ಅಂದ್ರೆ high level is not suitable. Suppose if you are developing the embedded software and developed with high level language, that is not suitable for the low level hardware ಅಲ್ವಾ, ಅವಾಗ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Okay, when accessing the low level hardware, the timing specification may be very critical and a class compiler generated in binary may not be able to offer the required time specification accurately. Writing the hardware some peripheral access routine in the processor or controller specific assembly language and involving interface C is the most advised method to handle the such a situation. Okay, ಈ ತರ ಸಿಚುವೇಶನ್ ಅಲ್ಲಿ ನಾವು ಏನ್ ಮಾಡ್ತೀವಿ, the ELP program ನಾವು high level language program ಅಲ್ಲಿ ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಯಾವಾಗ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಈಗ ಸಪೋಸ್ ಲೋ ಲೆವೆಲ್ ಹರ್ಡ್ವೇರ್ ಸಪೋರ್ಟ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ನಾವು ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ ELP program. Otherwise, some implementation, okay, some building implementation, okay, supporting call ಮಾಡಬಹುದು, service call ಮಾಡಬೇಕಾದಾಗ C language support ಮಾಡಲ್ಲ, ಅವಾಗ ಏನ್ ಮಾಡ್ತೀವಿ, ಈ ಅಸೆಂಬ್ಲಿ ಲ್ಯಾಂಗ್ವೇಜ್ ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ ಲ್ಯಾಂಗ್ವೇಜ್. Okay, next is the mixed assembly language with the high level language. ಅಂದ್ರೆ mixing assembly language. Okay, next. ಈ ತರ ಎರಡು ಸಿಚುವೇಶನ್ ನಾವು ಮಿಕ್ಸ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದೀನಿ, ಬಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ವೆರಿ ಈಸಿ. ಓಕೆ, ನಾವು ಮಿಕ್ಸ್ ಮಾಡೋದಕ್ಕೆ ತುಂಬಾ ಕಷ್ಟ ಆಗುತ್ತೆ. ಓಕೆ, ಮಿಕ್ಸಿಂಗ್ ಸಿ ಅಂಡ್ ಅಸೆಂಬ್ಲಿ ಇಸ್ ಲಿಟಲ್ ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಬಿಕಾಸ್ ವಿ ಹ್ಯಾವ್ ಡಿಫ್ರೆಂಟ್ ಸೋರ್ಸ್ ಕೋಡ್ ಅಲ್ವಾ. ನಾವು ಡಿಫ್ರೆಂಟ್ ಸೋರ್ಸ್ ಕೋಡ್ ಇರುತ್ತೆ, ಡಿಫ್ರೆಂಟ್ ಕ್ಲಾಸ್ ಕಂಪೈಲರ್ ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀವಿ ಅಂಡ್ ಡಿಫ್ರೆಂಟ್ ಡೆಸ್ಟಿನೇಷನ್ ಫೈಲ್ಸ್ ನಾವು ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಆಕ್ಚುಲಿ ಇನ್ ದ ಪ್ರೋಗ್ರಾಮ್ ಮಸ್ಟ್ ಹ್ಯಾವ್ ಆಫ್ ದ ಪ್ಯಾರಾಮೀಟರ್ ಪಾಸ್ ಫ್ರಮ್ ದಿ ಸಿ ರೂಟ್ ಇನ್ ಟು ದ ಅಸೆಂಬ್ಲಿ and values are returned from the assembly route into C, and our assembly routine is involved from the C code. Okay, a program ಗೊತ್ತಿರಬೇಕು ನಮಗೆ ಯಾವ ತರ ನಾವು ಅಸೆಂಬ್ಲಿ ಇಂದ ಸಿ ಕೋಡ್ಗೆ, ಸಿ ಕೋಡ್ ಇಂದ ಅಸೆಂಬ್ಲಿಗೆ ನಾವು ಯಾವ ತರ ಮಿಕ್ಸ್ ಮಾಡ್ತೀವಿ, ಯಾವ ತರ ಪ್ಯಾರಾಮೀಟರ್ ನ ಪಾಸ್ ಮಾಡ್ತೀವಿ ಫ್ರಮ್ ಸಿ ರೂಟ್ ಇನ್ ಟು ದಿ ಅಸೆಂಬ್ಲಿ, ಅಂಡ್ ಆ ತರ ವ್ಯಾಲ್ಯೂಸ್ ನ ರಿಟರ್ನ್ ಮಾಡ್ತೀವಿ ಫ್ರಮ್ ಅಸೆಂಬ್ಲಿ ಟು ದಿ ಸಿ ರೂಟಿನ್. Okay, how the assembly routines are involved from the C coders. Okay, that should know about these things. And passing parameter to the assembly routines and returning value from the assembly routine to the caller C functions. And the method of involving the assembly routine from C code is class compiler dependent. Okay, ಇದರೆಲ್ಲ ನಾವು parameter na pass ಮಾಡೋದು from C routine into the assembly and values are returned from assembly to C routines. Okay, ಅದು ಮಾಡಬೇಕಾದಾಗ you should know that awareness about the ಕಂಪೈಲರ್ಸ್ ಆಗ್ಬೋದು ಅಂದ್ರೆ ಯಾವ ತರ ಪ್ರೋಸೆಸ್ ಆಗುತ್ತೆ ಅನ್ನೋದ ನೀವು ತಿಳ್ಕೊಂಡಿರಬೇಕು. Okay, that's why you're using this kind of transfer between parameter or values between the assembly to C code. Okay, then that will be dependent on your class ಕಂಪೈಲರ್ಸ್. ನೀವು ಏನ್ ಕ್ಲಾಸ್ ಕಂಪೈಲರ್ ಯೂಸ್ ಮಾಡಿರ್ತೀರಲ್ವಾ ಸೋರ್ಸ್ ಇಂದ ಆಬ್ಜೆಕ್ಟ್ ಗಳು ಕನೆಕ್ಟ್ ಮಾಡೋದಕ್ಕೆ, ಓಕೆ, ಅದ್ರ ಮೇಲೆ ಡಿಪೆಂಡೆಂಟ್ ಆಗಿರುತ್ತೆ ಮಿಕ್ಸ್ ಮಾಡೋದು. Today we'll stop here, dear students. Today we'll stop here. We'll continue next class. Okay, any doubt regarding today's session, you can ask me any question now. Dear students, it is audible now? Say sir.
Yes, sir. Yes, sir.
It's in the assembly language with the high level language. Okay, today we'll stop here. We'll continue the next class. Okay, thank you.